video, I will explain numerical integration, focusing on three common methods, that is trapezoidal rule, the second is Simpson's 1/3 rule, and the lastly is Simpson's 3/8 rule. Alright, so let's get started in the first one. Alright, so the first one is trapezoidal rule. The main idea is to approximate the curve using straight lines. Alright, so forming trapezoids over its small interval. We define A as the lower limit, B as the upper limit, N as the number of some subinterval, H as the step size calculated as 0 B minus A slash N. In this method, the first and last functions values are counted once. All middle values are counted twice. The rule is simple and easy to implement, but less accurate for curves with high curvature. Let's get to the next rule. It is Simpson's 1/3 rule. The idea is this method improves accuracy by approximating the curve using parabolic shapes instead of straight lines. One important requirement, that is the n must be even. The step size h is calculated the same way as before. So you can see here in the requirement the n must be even, right? So in this method, the first and last values are multiplied by 1. Odd indexes values are multiplied by 4. Even indexes values are multiplied by 2. So this rule, as you can see here, this rule is more accurate than the previous one. It works very well for smooth functions and is what they use it in numerical analysis. The third rule is Simpson's 3/8 rule. The idea is this method uses cubic approximations, which can give better results for certain functions. The requirement here is the number of subintervals must be multiple of 3. The step size h is still calculated as b minus a divided by n, like before, like in the previous rule. The formula, as you can see here, this is the formula. In this rule, the first and last values are multiplied by 1. The values whose index is a multiple of 3 are multiplied by 2. All other values are multiplied by 3. This rule can be more accurate than Simpson's, the previous Simpson 1/0 rule, but it's more complex. So you can see that this is the comparison of every rule and their accuracy and their cons. The comparison, the trapezoid rule uses straight lines and is the simplest, but their accuracy is low. Simpson's sorry 1/3 use parabolas and offers high accuracy. The third rule uses cubic curves and can provide very high accuracy when its conditions are met. In conclusion, numerical integration allows us to approximate integrals efficiently when exact solutions are not practical. Alright, so that's all for me. If I say some mistake, I apologize. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.